Welcome to Chibuzor Mathphysics. This is Waves and Optics Part 2. I'll be dealing on the traveling waves and we do some calculations last time. Like you know, in this platform, we are dedicated to helping you uh, arrive to that potential you want to achieve in your academic endeavors. But bear in mind that doing all your homework and assignment might not be of help because I can't give you fish. I will teach you how to fish. All these things is all about following the concept. It is all about going systematically, know how to analyze the equation, know what you are given, and then what you are looking for, then to know the suitable formula to use. I decided to do this one as you requested, most of you requested on the comment sections below in the first video, the part 1. Many of you requested for this question. Usually I don't solve assignment, but then since many of you are actually confused about it, I decided to make a video for it. But then you need to follow the same approach in order to solve other related questions. So let me take you through it. In this question, we'll be having the reflected rays. We have something about the incident beam and the incident angle and also the refracted angle. Here is the question we're given that a beam of light traveling in air strikes a slab of transparent material. The incident beam makes an angle of 45 degrees with the normal, and the refracted beam makes an angle of 22 degrees with the normal. So, what is the speed of light in the transparent material? You are asked to produce the speed of light in the transparent material. See here, you have been given C. C is going to be, you will have when it is traveling in a vacuum and also when it is traveling in a medium. So it will represent the medium, and we are going to use those to calculate. And you are asked to provide the answer in this form where you will have whatever you get multiplied by 10 up to 8 meter per second. So let me show you what you are supposed to do. Now the refractive index is given by sine I divided by sine r. If you don't know how we get this, refer to my previous video where I proved this formula. So we are going to use this formula, sine I, the sign of incident, and this sign means the angle of incident and the angle of refraction. That now, if you look at our equation, you were given the angle of incident as 45 degrees and the refracted beam, that is the angle of refraction, it is at 22 degrees. So we are going to be using that in our formula. Just need to plug into it in your calculator. If you have your calculator, you can put sine 45, that will give you root 2 divided by 2. And if you standardize that, you will get 0.707 1. So you can just approximate so that we have 0.707. Then do it differently, sine 22. Sine 22 will give you 0.375. So if you divide both 0.707 divided by 0.375, you will get 1.885 in our equation 1. So we'll be using this as our refractive index, and this our refractive index, we'll be using it to calculate to do further calculation and arrive at the final answer. So now the refractive index is given already in terms of the speed of light, and we know that the velocity of light in vacuum will be divided by the velocity of light in medium. So it is simply the velocity of light in vacuum divided by the velocity of light in medium. And we were given the velocity of light in vacuum. That's why we had C to be 3.0 times 10 raised to power 8 meter per second. So this is the velocity of light in vacuum. So it is in vacuum, so we need to plug it into our equation. We are not given the velocity of light in medium, so it will be represented by V. So the C which was given is 3.0 times 10 raised to power 8 divided by V. Of course, this is our equation 2. So we are going to equal this to our refractive index. Remember, we already calculated our refractive index, and in the calculation, our refractive index was 1.885 approximately. So now, if we if we plug our refractive index into this equation, we will have 3.0 times 10 raised to power 8 meter per second divided by V, which is the velocity of light in medium, which is not given, to be equals to the refractive index. When we make this V the subject, remember V here represents the velocity of light in medium. So we just need to do the inverse of that. So it will be V to be 3.0 times 10 raised to power 8 divided by this refractive index we were given, which will be 1.885, and our final answer will be 1.60 times 10 raised to power 8 meter per second, as we are required to represent our answer in this form. And this is how we calculate the refractive index of a beam using the incident angle and also the refractive angle, the angle of reflection. I hope this video has helped you. This is the answer to your assignment and to your homework for those of you who requested for this video. And for you who are new in this channel, kindly subscribe. You help us to help you, as you all will move together in achieving our academic excellence. I remain your friend, Augustine Galagash. This place is just for physics and mathematics. And if you have more question and comment, just type it on the comment section below and let me know in case you have any clarification and maybe more work and you are having confusion. We are always there to help you. Have a nice day. Bye.